All right, how's everybody doing? Thumbs up, we're okay, still awake? Okay. So when Scott asked me to give a talk today, I broke it down into 3 sections. The first one's going to be, what did we see in 2021? What do we think about in disease risk, or how do I think about disease risk in wheat? And then finally, going to share some data with what can we expect from a fungicide when we have a different environment every year, okay? So everybody kind of got those 3 objectives? Ready to rock with it? So the first one I'm going to talk about is, what did we see in 2021? Well, it was a pretty boring year for me in my office. That's good. That means we didn't have much wheat disease. But the bad side means that we might have had some yield problems too. But there's one disease that I did get a few questions on, either text messages, photos in my email, and this was something called root rots. So to give a background history on root rots in wheat, they are an opportunistic disease. And their opportunity this year is we had stressed wheat plants, ones that are either fighting for moisture, ones that are having a difficult time establishing, and then you have these other critters, pathogens in the soil that take advantage of that. We often don't see a root rot problem in wheat until we start getting to grain filling stage. And at this point, you're going to see whiteheads in the field. Now, there are several things in the field that can cause whiteheads, but one way to separate this from anything else, if this pointer would work. All right, perfect. I'm going to do it the old-fashioned way here a little bit. It's not working right now. All right, perfect. See, I'm going to do this on the fly, so stay with me. So one thing you could take a look at is for root rots is you'll see the whitehead on the far right, be left-hand side, but start looking at the crown of those plants. You're going to see discoloration. You're going to see the root of the soil ball, the soil particle ball, to be a little bit less on a diseased plant. And how I think about this is, over time, just think of a slow choking pathogen that is going to cut off all that vascular tissue, and then we get the whitehead. So what does this look like in terms of, are we worried about it in yield loss? Well, it depends on the situation. There's a couple things how I look at yield loss from root rots is one thing I call human nature. In human nature, we're always trained to look for the one thing that looks out of place, right? So what I want you to look at specifically in this photo is we have a bundle of white plants right there. That's a root rot. That's a common symptom that you'll see in a field of root rot. Sporadic, here and there, main stem and its tillers. Now, how do I estimate yield loss on that one section of the field and then try to count every other one? Pretty difficult, right? But I can guarantee that sometimes we may overestimate how bad the situation is at the same time. So if you want to talk to me as far as what I think the worst root rot field I saw, maybe 1% of the field was impacted. On a whole statewide basis, if I put everything together, we're less than 0.25%, less than 0.1%. So is it something that we can manage? Well, there's not much we can do for it at this point. We certainly have some seed treatments we can put on early on in the season, but they're going to run out. A lot of times when these root rots are taking effect is later on in the season before we can even have the management. So if I was up here to give my 2021 wheat disease update, we're done. Okay, we're going to dive into this a little bit more. So if I'm thinking about what happened last year, and I could pull back to 2019, 2016, 2017, one thing that's common is we never have the same disease risk each year. So my lesson on the first thing is, this is the first time I've ever presented this as a disease triangle. And I'm not just going to present a disease triangle and not give a little bit of practical knowledge, but there's 3 corners that I want to just apply a little bit more. One is I consider the most important is host susceptibility. Now, we have several varieties in the state, and we have the disease scores associated with them, but how we apply host susceptibility is going to depend on a few things. First thing might be, what diseases are you worried about? Which ones have been more frequent in your area? We don't have a variety that's going to be good on everything. So when we look at a host susceptibility as far as our risk, if we're looking at something that we want management for bacterial leaf streak, all we have is host resistance. There's nothing that we can spray on a bacteria that's going to get us a return on investment or improve our yield. So when we put that seed in the ground, that's our management tool for bacterial leaf streak. If we start looking at fungal leaf spots, our broad range of values that we have in host resistance. Some are a little bit better than the others. There's nothing out there that is immune. There's nothing out there that I would consider extremely susceptible right now either. We just know that all varieties have a different reaction. The other thing I know with fungal leaf spots is we're commonly spraying for them each year, or we're commonly doing cultural practices to help reduce it. So if I'm looking at host resistance and applying it to 2 different foliar diseases, it really depends on which one you're most worried about on an annual basis. Contrast that with the head disease of Fusarium head blight. Again, host resistance starts with it. We don't have an immune variety of Fusarium head blights. We always got to give as many management tools as we can. Now, I can't predict scab risk for next year, but I do know if you put a mono-resistant variety into the ground, you're going to be starting off on the right foot instead of maybe starting behind the 8 ball. The next thing to consider is the pathogen, and I know we have pathogens out there, and I can go into race talks and rust diseases, but really when I think about the pathogen in this sense is availability. And the 2 things I'm going to show you or think about is residue. So if we think about the fungal leaf spotters, they love wheat residue. That's how they overwinter. They actually need the winter to condition themselves, and as soon as they hit the spring rains out there, they start to mature and release spores. But if you practice anything as far as crop rotation, or maybe even some type of tillage, you reduce that risk considerably from fungal leaf spots. The other thing to know about fungal leaf spots is understanding the biology of that pathogen. And to try to simplify it, some work that was done down in Kansas State is they were tracking spore travel from the fungal leaf spot pathogens, okay? So the idea is how far do these spores travel in generating disease? Now, you can track spores into the atmosphere almost a half mile up, but just because a spore is there doesn't mean that it's going to infect. So what they determined is when you look at the tan spot pathogen, is that initial spore flush, they travel about 6 inches. So what is one thing I'm going to talk about in that regard? Crop rotation, any type of tillage, you're going to be starting off on the right foot. If you get a tan spot infection on a leaf, the spores that they generate about 30 yards. Okay? So just understanding a little bit about the biology and what tactics you're already using could influence your disease risk. Now, if you're in a minimal till, weed on weed type of situation, you can see how if you have a couple million spores in the field, it's not going to take long before you have an epidemic to occur. The other pathogen I always bring up is Fusarium head blight, how it overwinters on corn residue. All these black specks that you see on this corn residue, that's just the Fusarium head blight pathogen ready to release. Now these are a little bit more conditioned. They can travel a little bit farther, and because you have corn residue, it sticks around for a while, doesn't it? So the first year out of corn is the greatest chance these spores are going to germinate. Each year it reduces it about 50% viability. But the understanding is that we have plenty of pathogen inoculum out there, and what influences it is oftentimes our last corner, environment. I'm not going to give much practical knowledge in environment. How I talk about it is 2021 was the year, 2017 was this year, 2018 this was the weather. We know we're going to have a changing environment, and the factors that I look at most often are dew and frequency of rainfall. The reason I say frequency is sometimes we get these 5-6 inch soakers, but then that might be the only rainfall you get all year. So is that going to impact the disease? Well, right away it is, but it's going to run out as far as that favorable condition. So this is the disease risk, how I look at, but what do we get to as far as the fungicide response? I know this is a long way of getting there, but the question that I was trying to get to is how do I interpret disease risk each year, and what can I expect from a fungicide? So there's a couple data sets I'm going to run through. A lot of these are multi-location, a lot of years of generation, just to try to get a more precise measurement of disease response. The first one I'm going to look at is I looked at data from 2008 to 20 and 20. So the good thing is I have about a different disease risk each year. But how do I start grouping these together? What I did is I took all these trials that were the target diseases are the fungal leaf spots, think of tan spot and rust, and only 2 individual fungicide timings. One is the tillering, which you put in with that first herbicide pass, and the other one was the flag leaf application. From these environments, I created 4 disease risk categories. In other words, I'll get to these in a little bit, but how I was able to categorize them and then look at responses when it pertains to yield. So what factors do I look at if we want to think about disease risk categories? Here are the factors that I consider. variety, the previous crop, tillage, dew periods, rainfall, when the disease started to occur, because the earlier a disease gets into a field, the greater the chance of yield loss, and then finally year-end disease severity. So what are these four categories that I create? I created a very low, moderate, and high. Now you can I'm not going to run through each one, but you're going to see a couple common trends here based off disease risk when I was talking about it previously. One was the use of variety, one was what type of pathogen availability was there already, and then we talk about the environment, right? So which one that was often influencing most of the disease risk each year? Host selection, variety resistance. Okay, so here's our four disease risk categories. What happened when we would apply these fungicides in these environments? So the chart I'm going to show you is you're going to have two bars. One is the tillering application, one is the flag leaf. And then we're looking at the yield response. The yield response was generated by taking the percent response from the non-treated check in that environment. Okay, so everything is in percentages here. And how to apply it is take your estimated yield potential on wheat you have in your field and then apply the percent to that. So the disease risk categories on the bottom, when we look at that tillering application, probably not alarming, right? The higher the disease risk, the more response you're going to get from that type of a fungicide application at that early timing. When you start having these low disease risk years, you start running if you're able to even get that return on investment in that case. I understand that there's different fungicides, there's different price points, so again, take it for what fits your system. When you look at the flag leaf applications, similar trend, right? So everybody's kind of looking at this 19% yield response in a high disease environment. Yeah, I've seen that. If we have a rust disease coming early in the state, if you have an unmanaged tan spot type of epidemic in your field, that application at flag leaf is going to save it. What do we generally do in North Dakota? If I were to say based on this area of the state, we're probably more likely in this area each year. This type of high disease risk environment is me doing everything wrong in terms of disease management. I like to think that our growers are doing everything right, so we're always going to be in that low to moderate risk. So this answers one question about foliar fungicides at the tillering and flagging time, but this question that I thought about after developing this data set is, what is the response on a variety, right? So I often get asked questions about a specific variety data for fungicide. So what I started back in 2021, this past year, is I got funding from SBARE and the North Dakota Wheat Commission, and I did a fungicide by variety trial across the state. And I set it up at 4 locations, Carrington, Fargo, Minot, and Hettinger, working with the RECs. And what we're looking at specifically was I chose 3 varieties and 4 fungicide treatments that I would consider to be pretty or 3 fungicide treatments that were pretty common in the state. When I selected these varieties, I looked at popularity as far as acreage in the state, but I also looked at what was the response on fungal leaf spots, because if we're looking at that tilt application or propiconazole generic application early on, that is our target disease. That is what we're looking for early disease management. So you take these 3 varieties, the 4 treatments were non-treated, tilt, Prosaro, and then the combination of the 2. How did it perform across all these environments? Again, I'm trying to fine-tune this a little bit more to get to a more variety-specific responses. So what happened this year? Fargo and Minot had no disease. Carrington had significant moisture stress early on where we weren't able to get enough stands, so I kind of more or less threw the data out from the past year. But in Hettinger, we had a very late disease onset of tan spot. And when this tan spot came in, it was probably around the flowering stages as I was moving up into the canopy. So to break this data set down from this past year, I looked at the yield response from these no disease locations, being Fargo and Minot. Each variety on the bottom here, non-treated control, tilt application, Prosaro, tilt followed by Prosaro. Guess what type of trend we're seeing? Low disease risk, not seeing much of a yield response no matter what variety we're throwing at it. Okay, now let's look at that outlier location of Hettinger. Again, I mentioned had a little bit later disease onset, there was disease present. Looking at the disease data first, the higher the value here, the more disease that was in those research plots. you're going to see that the influence of host resistance kept those disease levels at bay regardless of application. That's probably to be expected. Vitpro and Valda tend to be a little bit more susceptible to tan spot. You notice that because I said it was a late disease onset, that early application had little or no effect on it, because when you spray it early on, you're not protecting those leaves that are coming out next week, right? So all again kind of makes sense, but we did see an influence of the Prosaro application by giving that late season management. Sometimes that is often used when you think about first spraying for scab. What did we see from the yield perspective? Pretty flat again. So why? Remember things, when we think about critical growth stages, we're protecting flaglets. Once we get up beyond that grain fill, yes, we did see a response from a fungicide, but regardless of variety, we weren't seeing much outside of that. If we had an earlier disease onset, I guarantee that we'd be able to see more separation. So this was a good start. I'm hoping to do this again next year, maybe even adding a 5th location just to give me more environments and give me more time to generate data. The last thing I want to talk about is what about spraying with a low scab risk? And this was more or less what Scott asked me earlier in the season. So before I get there, I want to review what we should be doing for scab management. And I summarized this in one slide. First thing, host resistance. I cannot stress that enough. Even if you use a susceptible variety in a moderate risk year, you can sometimes you might be able to get docked at the end of the year with just a little bit elevated DOM levels. So I say host resistance, start off on the right foot. We have fungicides right now. We have what we call good fungicides. We have Carumba, Prosaro, Miravasace, and Proline, all rated about a good. The Foliar and the generics out there are about fair. If you want to turn this into percent reduction of the disease, these will offer 50, maybe 60%, 20 to 25% is what I would call on a multi-year assessment. The best timing, regardless of the fungicide, our window of application begins at early flowering and extends 7 days. How I say that is you have a window of about 7 days to make an application for scab to reduce disease in the field and reduce DOM. So there's a couple things that we're able to generate. We're not so strict on a 1 or 2 day window. We have a little bit of flexibility when Mother Nature throws at it. The other thing that's occurring in the future, we have 2 new fungicides that will be on the market this year. One is Prosaro Pro, and one is Spirix. Prosaro Pro out of Bayer and Spirix out of BASF, meaning that we have more tools in there. Now I do have data available on both these fungicides. I just won't be going over it today, but just wanted to give you what the scab management outlook looks like right now. So if we're spraying in a low risk year, what can we expect? Well, luckily, through funding for the U.S. Elite and Body Scab Initiative, I outsourced about 13 trials we conduct across the state. And what I did is I took the Harvard spring week data from the Carrington location, which is under irrigation, Fargo, which is dry land, and then the Langdon, which is also under irrigated. Across these trials, these were the 4 varieties that were looked at. Mayville and 9719 tend to be more susceptible to scab. These, what I would call is middle of the road to slightly better for scab resistance. And all these locations had DOM levels less than 0.5, meaning that it wasn't completely void of scab, but it was pretty low regardless. And I looked at the yield trends. So the yield trends that I'm looking at, the non-treated control, Miravasace applied at half head, and then Prosaro, Carumba, Miravasace, or Spirix at that early flowering timing, okay? So just kind of think about this as low disease risk. Does the fungicide going to influence the response? So so after I combined the data, what did we see? Here we have the yield values, so actually bushels per acre. The non-treated check was 61 bushels, and every fungicide was higher in yield. And it was consistent, meaning that there wasn't any differences amongst the fungicides. So I just said that if we spray in a low disease risk year, how am I getting a significant yield response, right? Now I got to remind you, foliar disease levels are not recorded, but I can almost guarantee under any type of supplemental irrigation, when we don't have anything for early season protection, we're likely getting some yield benefit from that application later on in the season. The second thing I wanted to mention is the responses varied by environment. The lowest response we had was in the Fargo dryland environment, and in most cases was maybe a bushel or 2. Okay, so again, this is the benefit of combining data, but again, got to interpret it a little bit more too, and other factors that may be occurring in those trials. So a couple take-home messages, and I hope these kind of resonate with you. Is disease risk is always going to be variable. Understand what you're doing from a management perspective and how that is influencing. I still believe that fungicide decisions for fungal diseases need to be a scout-based approach. The reason why I say that, if you're conventionally tilled, if you're putting crop rotation involved, and you might be wondering how much fungicide or what fungicide to put on early on, consider what tools you already are incorporating and what can you expect from that fungicide application. Fungicide response or yield response is greatest in high disease scenario, but with all these diseases, how do I start prioritizing? So the final thing I want to give you is my game plan for 2022 is A, what diseases are you most worried about? If you're worried about bacterial leaf streak, understanding when that seed goes into the soil, that's the only management tool you have. But also understand what current tools you're already in use. If you always put fungicide in with that herbicide pass, if you're always going to spray for scab, what does that level of disease risk even influence if you do maybe put weeds after weeds in a situation that you're hamstringed by? And finally, always diagnose diseases during the season to make sure you know you can do something about it. 2 years ago, when we had a lot of bacterial leaf streak, we had a lot of misidentification of fungal leaf spot. And they were spraying based off of thinking they were managing fungal leaf spot instead of bacterial leaf streak, where fungicides would have no response. So again, it's always good to kind of review, keep notes, keep that crop history to understand what you can do from a management perspective. So with that, that's all I have for you. What type of questions do we have this morning? Oh, great question. So the question is, have we seen any fungicide resistance issues with these chemicals? And in the wheat crop, and I'll just speak on the wheat diseases, we have not seen any resistance issues. Now there are a couple different groups that are looking at it. We're looking at the tan spot pathogen currently as part of the study for fungicide resistance issues. And then the more common one is about Fusarium head blight. What they found with Fusarium head blight, there's nothing in the U.S. or in our state that suggests that we have any resistance developing, and there's still going to be good management tools. The good thing that I like about the fungicide resistance realm is when Mirabizase came on the market, its primary contributor to reduction of disease is a SDHI, it's a non-triazole, so that's helping our fight for any future instances where we might run into some issues. So, good question. Yeah, so the question is, what can we think about for scabrous for last year coming off a dry year? One thing is Fusarium is always going to be around. And I have instances where you insert a disease, if you're coming off a dry year, the next year might be your worst disease for a water-loving disease. So it's really the environment that drives it in the current year. And there's plenty of corn residue out there, and that pathogen is always more or less going to be around. So don't think of it as I don't need to spray next year because we had a dry year. It's stay on top of what's occurring during the growing season.